All right, guys, so today we're going to transition into solving literal equations. So literal equations are something that a lot of students typically have a lot of issues with because when you get your answers, they don't necessarily look exactly right or finished. But if you follow your steps and follow your rules, you should get to the exact same place that you would if you're solving normal equations. Okay, first of all, what is a literal equation? It is an equation with two or more variables. So for this first set of bullet points, you're going to put in two or more. Okay. So what does it mean to solve a literal equation? In standard form, if I ask you to solve for y, what that means, I want you to get y all by itself. Okay, you couldn't be dealing with multiple variables in a literal equation. If I ask you to solve for y, it means y is the variable we're trying to get all by itself. Move the x's, move the z's, move whatever else you see to the other side of the equation, of the equal sign. Okay, so let's do an example. The first one we see here is negative 2x plus 5y minus 4 is equal to negative 17. And super, super important, you got to read the directions. It says solve for y. So our goal here is we want to get y all by itself. Okay, we want to move all the other stuff away from it. Okay, so what do we see? We see a negative 2x on the left, we see a 5y on the left, and we see a minus 4. Let's just start moving things away from that y. First thing I would probably do here is I would add 4 to both sides and see if I can combine any like terms. Okay, after I add 4 to both sides, I'm left with negative 2x still on the left. I still got a plus 5y on the left. And then on the right, I see negative 17 plus 4, and that is equal to negative 13. Okay, ask yourself this question. Is y by itself yet? No, it's not. So I got to still move this negative 2x over to the right. Okay, so here's the nice thing. If you're dealing with variables that aren't the one you're trying to solve for, you basically just treat it like a constant or like a number. Okay, so we see minus 2x here on the left. And if my goal here is to move this entire thing over from the left to the right, all I got to do is just treat this like subtraction and use addition. So I'm subtracting 2x from the left. In order to get rid of it, I need to add 2x to both sides. On my left-hand side, I'm just left with 5y. And then on my right-hand side, I see 2x. I can't combine that with minus 13, so it stays apart from it. 2x minus 13. Okay. Is y by itself yet? No, it's not. It's still got that 5 next to it. I see 5 times y. How do I get rid of multiplying by 5? I have to divide by 5. So when I do this, watch closely, I'm dividing my entire left side by 5, and I'm also dividing my entire right side by 5. So what I'll have left is I'll have y on the left, and on the right, it looks super ugly, but that's about as simple as we can get it. It's 2x minus 13, and all of that entire right side is being divided by 5. Y is by itself, and this is solved for. Okay, let's look at example B. Same exact directions. Solve for y. Get y all by itself. I see 4 times the quantity, y minus 2x is equal to 9 minus 3x. Okay, whenever you see this sort of format of a number and then stuff in parentheses next to it, it's always probably a pretty good idea to distribute. Take this 4 and distribute it to both the y and the minus 2x. After you do that, you're going to have 4y minus 8x on the left is equal to 9 minus 3x on the right. Okay. End goal is still the same. I want to get y all by itself. Let's start moving stuff away from it. I see a 4 and I see a minus 8x. Let's just treat that minus 8x like it's a number or it's a constant. In order to get rid of minus 8x, I have to add 8x. Add 8x to both sides. Super, super important. Make sure you're combining like terms. On your left-hand side, you're just left with 4y. And on your right-hand side, you see 9 minus 3x, but I have to add 8x to that. So these two terms are combinable because they have an x attached to it. The 9 stays separate, so I see 9, and then negative 3x plus 8x is going to be equal to plus 5x. Okay, super, super close. Is y all by itself yet? No. I got to get rid of that 4. How do I get rid of that 4? I have to divide both sides by 4. 4 times y, the way we get rid of multiplying by 4 is dividing by 4. If I divide my entire left side by 4, I got to divide my entire right side by 4. Now we left with y is equal to 9 plus 5x, and all of that is being divided by 4. Once again, a super, super ugly answer, but we know we're good because y is isolated. All right, let's keep going. Same directions for example C here. We see 1/5 times the quantity y plus 2 plus 5x is equal to 8x. What's the end goal here? We want to get y all by itself. We see 1/5 times all that stuff next to it. Let's take that first step and distribute this 1/5 to both the y and to the plus 2. Okay, 1/5 times y is just 1/5 y, kind of ugly, but we can deal with it. Plus 1/5 times 2. Okay, if you want to go off to the side here, what's 1/5 times 2? Times 2 over 1. It's the exact same thing as 2/5. 1/5 times 2 is plus 2/5. On my left side, I still see that plus 5x, and then on my right side, I see equals 8x. Okay, what's the end goal here? We want to get y all by itself. Let's just start moving the stuff away from it. Okay, you see a 1/5, you see a 2/5, and you also see a 5x on the left. Let's move that 5x first, get that thing out of the way. So how do I get rid of adding 5x? I need to subtract 5x. Subtract 5x from both the left and to the right. And what am I left with on the left side? Still have the 1/5 y, have not touched that yet. I see the plus 2/5, still have not touched that yet. And on the right side, I see 8x minus 5x, and that's equal to 3x. Okay, let's keep going. I see 1/5 times y plus 2/5 is equal to 3x. Remember, what's our goal? We want to get y all by itself. What do I want to get rid of next? The 1/5 or the plus 2/5? Okay, always do addition and subtraction before you do multiplication. I'm going to subtract 2/5 from both sides. Okay, what I'm left with is 1/5 y, still have not touched that, is equal to 3x minus 2/5. Is there any more I could do to simplify that? No, keep them apart. Don't do extra work if you don't need to. It's still just 3x minus 2/5. Okay, now we're super, super close. I see 1/5 y is equal to 3x minus 2/5. So my end goal here is I want to get rid of that 1/5 next to my y. What do I need to do? Okay, couple different ways you could get rid of this. This is the same thing as y divided by 5, or it's the exact same thing as 1/5 times y. Now, thinking back to last chapter, how do we get rid of fractions? Easiest way is probably to multiply by the reciprocal on both sides. Okay, so what am I going to do? In order to get rid of 1/5, I'm going to multiply both sides by the reciprocal of 1/5. The reciprocal of 1/5 is just 5 over 1. It's a fancy way to write 5. But whatever I do to the left, I got to do to the right. So I'm also going to multiply my entire right side by 5 over 1. Okay, let's see what happens here. The 1/5 cancels with the 5 over 1, and basically what I'm left with on the left side is just plain old y. That's exactly what I want. But now I'm going to multiply my entire right side by 5 over 1, or another way of saying just 5. Okay, so what am I going to do here? I got to distribute this 5 to both 3x and the minus 2/5. Okay, 3x times 5 is going to be equal to 15x. And then I got minus 2/5 times 5 over 1. I do that off to the side if I want. 2/5 minus 2/5 times 5 over 1. What's going to happen here? This is going to cancel with that, and this becomes a 1 and a 1. Negative 2 times 1 is equal to negative 2 over 1. That's just equal to negative 2. So 5 over 1 times minus 2 over 5 just becomes minus 2. And when I isolate y, it's equal to 15x minus 2.